His phrase about which point is probably not a good phrase, because what you hopefully noticed here and what he's trying to get at is anytime you equalize it, anytime you open that valve, the pressure is going to be 15 because the molecules are going to go either out into the air or into the container from the air. And so this vertical line at 15 would then tell me where I equalized it. You see where the 15, that means 100, that means I must have equalized it in the boiling water. Now mine doesn't look real well because this one then should have crossed at 21 and this one should have crossed at 0 and this one should have crossed at negative 64. So it's not so much a point as a line, and that's what he's getting at in that one. And then the last one says, why is it essential that the temperatures used in predicting the gas pressure be absolute? And so let me point out the same thing I was trying to say in class. And I really like this question. It's not worded real well, but I really like it because one of the things I said in class, and we'll repeat now, that it is very easy and very common for students to make a mistake on the homework, on the labs, and on the tests. When they go to use this as a calculation, PV equals nRT, they use temperature in the Celsius scale instead of the Kelvin. So remember, the Kelvin scale is the only one where the numbers on the scale correspond to the motion of the molecules. So it is essential that when you use this equation, that's what he's trying to say, is really when you use this equation, what temperature scale should you use? And I shouldn't say should, must use. You must use the Kelvin scale. This is set up so pressure, see, when would you get zero pressure? At zero temperature. But 0 Kelvin, never 0 degrees Celsius. So that's what he's trying to remind you of. And I will take that moment too to say, always, always, always use Kelvin when you're doing your homework. Even when the problem on the Kelvin scale starts off, and you have a lot of them this way, that start off and say, the initial temperature is 21 degrees Celsius, blah, 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 blah. What you got to do then is that's a clue that you can't start using this formula until you convert 21 degrees Celsius into its equivalent on Kelvin. Okay? That's real important. All right, well, that's the lab for today, and I will then see you tomorrow.